Hello! In this video, we are going to prove the following theorem. For all negative integers a and b, we have that a plus b is a negative integer. Now, in this series, we are using a list of 10 axioms for the real number system, and I'll leave that list of axioms in the description below. Now, in our real number system, we have defined the positive integers as a subset of the real numbers. And we have shown for all positive integers a and b, a plus b is a positive integer. And so we'll refer to this result by saying the positive integers is closed under addition. Now, we define the negative integers as the set of all real numbers n that have the property that the negative of n is a positive integer. And in proving this theorem, we're going to be using the following preliminary result. For all real numbers a and b, the negative of a plus b is equal to the negative of a plus the negative of b. Now, to see how we can prove this, we're going to apply axiom 3, the distributive law, and the following preliminary result, which we have proven. We have proven negative 1 times x is equal to the negative of x for all real numbers x. So first, by our preliminary result, the negative of a plus b is equal to negative 1 times a plus b. So then, by axiom 3, we can distribute to negative 1 across this parentheses. And then, by this result again, negative 1 times a is equal to the negative of a, negative 1 times b is equal to the negative of b. So, through this chain of equalities, we have shown that these guys are equal. Okay, so now let's get into proving this theorem. To start the proof, let's first give ourselves two arbitrary negative integers, a and b. From here, the whole goal is to show that a plus b is a negative integer. Now, by definition of the negative integers, since a is a negative integer, that tells us a is a real number such that the negative of a is a positive integer. And also, since b is a negative integer, that tells us b is a real number such that the negative of b is a positive integer. But then, using the fact that the positive integers is closed under addition, well, since negative a is a positive integer and negative b is a positive integer, we have that negative a plus negative b is a positive integer. But then, by this preliminary result, which I will call star, we have that the negative of a plus the negative of b is equal to the negative of a plus b. So since these guys are equal, we can replace this guy with the negative of a plus b. So we have that the negative of a plus b is a positive integer. But then, by definition of the negative integers, since the negative of a plus b is a positive integer, that tells us that a plus b is a negative integer. Because, according to our definition, if we take n to be a plus b, well, it is true that a plus b is a real number, and it is true that the negative of a plus b is a positive integer, because that's what we have right here. Therefore, that tells us a plus b is a negative integer. So what we have shown here is, if a and b are any two negative integers, then it follows that a plus b is a negative integer. And that is exactly what we wanted to prove. So this completes the proof. So in other words, we have shown that the negative integers is closed under addition. And so yeah, that's pretty much it for this video.